Let me just verify with you. Can everyone see my screen?
Yes.
Thank you. So this is the PDH project management, things to keep in mind. And generally, I want to go over the following topics today, like why do we use or should we use methods for software development? Why do we use standardized procedures? What are the difficulties when it comes to the requirements and figuring out the requirements? Keeping track of time and how we useful things to keep in mind there. How agile development can help us in certain cases, and in the end, a short summary. So let's get started. Why do we use methods for software development? A very good example for a process where software development methods should have been used is the Ariane 5, which was launched in 1996. It's a European rocket that was intended to put commercial goods like satellites for communication into Earth's orbit, but the maiden flight failed and the rocket got destroyed. This was a huge surprise because Ariane 5 was built upon Ariane 4, which didn't have any issues. So what went wrong in this process? So generally there was the error with the launch, and the rocket lost control after about 37 seconds after the start. The reason for that was that wrong control signals were sent to the engines, which resulted in the rocket breaking apart and effectively destroying itself. The system error was a direct consequence of a software error. In fact, it was only a simple conversion from a 64-bit floating point number into a 16-bit signed integer, which failed and resulted in an overflow. There was no exception handling for this conversion, and therefore the system exception manager was activated, but with the functionality that the software was deactivated. The system didn't have a fail-safe state, obviously, and the backup software, which was started right after, was an exact copy of the other software, so it showed the same behavior that resulted in the system to be shut down. Now let's look at it in more detail. How did it come to that failure? Overall, the issue was that software from Ariane 4 was reused, and even worse, the part of the software that caused the overflow was not even required code for Ariane 5. So management made a bad decision there. So the problem was that they decided not to remove the module because that could have caused new errors. And they didn't check for overflows because there was no requirement that would have checked for overflows, because the module itself didn't have requirements, as it was seen as something that is just there from an earlier code. Because Ariane 4 had a lower launch speed, in that case, it wasn't possible to get an overflow, but with Ariane 5, that case happened, which resulted in that fatal error. Now let's look at why those things happened. So exactly, like there was no requirement for the module. It was not necessary for the rocket. So people were thinking we don't need to look at those additional things. There were no requirements, meaning there were no tests. So there were no requirements that were tested against, so nobody noticed that there was anything wrong. On top of that, in the system test, the inertia reference system was simulated, so the values there were slightly off as well. And then again, those values couldn't really be detected because there were no requirements that would have called for certain values not to overflow. Therefore, we have certain lessons learned from this incident. We always have to test beyond what the system is supposed to do, so we have to test on things that the system might do that we don't want it to do. Generally, for systems without a failed state safe, it is not a safe reaction to just shut the system off. So the general rule of having the general exception of shutdown must be deactivated for those systems. In critical calculations, if we cannot return a valid value or the best value, it is important to have backup values that are just as good as possible. They might not be 100% correct, but to make sure that the software doesn't crash completely. In general, if we have the chance to, we should use real equipment and not simulations, because with the real equipment, it would have been noticeable that the rocket would be faster and cause that issue. Generally, it has to be said that all assumptions in the source code must be checked. We can't just say, oh, this module was fine in another condition. We don't have to check what is there. It will not cause any issues. So that brings us to the next question. Why do we use those standardized procedures based on top of those standardized methods that help us to find issues? So with the standardized procedures, we have a necessary requirement for uniform use, meaning that if we build our software uniformly, we can apply it to new modules, we can reuse it, we can change it, and it is not horrible to work with it. For example, a typical standard for programming is to have imports first, followed by classes and function, and then write the calls to the function. If you think about reading different code and how difficult it is for other people to work with it, it would be way harder for people to like outsource or have other companies process suborders if the original system is written in a horrible way. Generally, those standards help us to ensure the integrity of the deliverable because we have intermediate results that we check against the requirements. And we can therefore validate and verify what we have earlier and can find critical errors before it is way into the development process. On top of that, due to using standardized procedures, it is easier and more transparent to calculate the expenditure because you can rely on data of earlier events or earlier projects. Now, I've been talking about the requirements a lot and how we check against the requirements. So I want to talk about the difficulties that project managers and technically team leaders in project management like roles face a lot. So the requirements themselves define the qualitative and quantitative properties of a product. In general, that sounds like a really easy task, but it is very hard to realize. So requirements can be ambiguous, they can be unaccomplishable, sometimes things can be overdetermined, they can be incomplete and inconsistent. So if you talk to the customer to determine what they want, they will not give you a list of requirements with like those are those functionalities we want, this is this, but it will more be like a wish list, and many of those things will be hidden in conversation. So the customer might only mention once that the requirement is that they want the object to be blue. They might not even mention it as a clear requirement, but if it's in the document with like their wish, then it has to be like taken account of. So let's go through a couple examples that customers might have as wishes. So they might be talking about like a bike like gyms, and that's where we already start struggling because we don't know exactly what makes a bike like gyms. If we know exactly what bike gym has, we can find the same bike, but which criteria can we change for the bike to still be like gyms? That makes the requirement very ambiguous. And when we're trying to write down the requirements, we want to avoid that at any cost and make it more clearly so we can actually see if we're doing what we're supposed to. A round ball would generally be overdetermined, and we try to avoid those things as it gets harder to read and states the obvious twice. There might also be unaccomplishable goals, like crazy example, meeting Santa Claus. Can't really help there, but it might be like sometimes that the customer wants something that is really cool. We can see that it's cool, we would like to have that too, but at this point in time, we don't have the technical means to accomplish it yet. Oftentimes, we can also have the problem that a requirement is incomplete. For example, a couple semesters back in one of the EPICS team, there was a really cool project with a desk that could be lifted up and set down again for a student. The problem was that the team never really talked about the size requirements, and when they delivered that desk, the desk worked amazingly, it was amazing, but it didn't fit into the student's room. So it was a complete failure as the target group never was able to use it. So it's always important to think about when taking those requirements, what are things that the customer has not talked about yet that we need to know to be able to know what our requirements are. And oftentimes, for example, if we are working in a certain area like electrical engineering or mechanical engineering, we might know what we need to know, but the customer doesn't really know what they have to decide on. So we have to prompt them to give us the information we need. Oftentimes, the customer might also give us inconsistent information, like they want a fast car and a classic car. To some degree, we could fulfill those wishes, but at some point we'd have to do a trade-off, like the typical classical car won't really be as fast as one of the Formula One cars, and it's where we have to clarify with the customer what exactly they want. A good example for those things is this caricature. So in many cases, the customer has an explanation and we are talking to them, but we understand something completely different. And over the course of the project, this project gets a little bit away from the original implementation, so it changes again. And oftentimes the customer really can't explain what they want. Like they might know what they think they want, but it might not be what they actually need. And it is the task of us to like mediate those problems. There are two types of requirements that we're usually looking at. First, what makes those requirements good? So as you've seen before, there are those issues that can happen if our requirements are not taken properly. And it is important to distinguish between things like a good requirement tells us what the product should be able to do, what it looks like, and which means we want to use to realize it, but we're not talking about how exactly we realize it. So a perfectly valid requirement would be that we want to realize it in Python, but the moment we talk about how we are going to modularize the problem, we are not in the requirements definition anymore. So this is not allowed at this point. So only in a later step in the development process, we will actually decide on those. It is important to note that the requirements are usually formulated in one big document with a clear structure and subchapters and subchapters. And in the traditional development process, this file is used to talk to the customer mainly and verify with the customer that we understand what they are trying to tell to us. So oftentimes this document is the basis for a contract, so it is important that this document actually captures what we are supposed to do. Every requirement must be clearly identifiable and testable. So for example, if we have a ball that the customer wants us to be blue, we can clearly say the object has to be blue and we can test that. But for example, if we say the software must have a good response time. What is a good response time? And we have to identify the actual numbers with the customer to figure out like what we are testing against. As mentioned before, it is important that we have complete and consistent requirements, and it is important that we talk to the customer to fill in the gaps where we feel it is inconsistent or incomplete. So over time, it gets easier with more experience, but in the beginning, that's a really hard task because you pretty much have to know what exactly it is that you haven't been informed about. The other thing is that it has to be comprehensible. So it should be written in natural language, not have formulas, no coding language. And images are always a good thing. So this document will be used by all departments. So mechanical part, software part. It will be used to communicate with the business side and the customer. So everyone should be able to at least understand the major part of the requirements. And if we write them in a too technical way, neither the customer nor most of the employees are gonna see the big picture, so it's important to do this properly. On top of that, we don't only have like requirements in general, but we distinguish between two types of requirements. On the one hand, we have the functional requirements, which are usually referred to as the more important requirements because they describe what a developed system is supposed to do. That can be a lot of things. So it could be a functionality, like we have an algorithm, and that algorithm should sum up two numbers. And then like the data, so we have two input numbers, we have an output number. And it's also important to define the interfaces as functional requirements. For example, if we have some hardware that is addressed via the backend over some app, then we have to make sure that the interfaces between those three systems are defined properly, that the interface to the user is defined properly, and that generally, whenever we encapsulate a subpart of the project, we make sure that it communicates with the other parts properly, and we can ensure that by like defining the interfaces beforehand. So for example, we have a module A and a module B that will interact together, but we'll be developing on both at the same time because we want to save time. So it is really important that we declare beforehand how exactly we are going to merge those two together to have a functioning product in the end. On top of those functional requirements, we also have the non-functional requirements. Those describe like what properties should the system have on top of the functionality. This can be performance requirements, so what is the number of users that access a certain system, what is the data volume it is supposed to handle, and those again are written in a way that we can easily define with tests if we fulfill the requirement or not. We also have quality requirements like safety, reliability, robustness, and there are implementation requirements concerning documentation and guidelines. It is important to note here that when it comes to guidelines, it is our task to figure out what those guidelines are, because the average customer will just mention, hey, I want this and that. And project management has to talk to the different parts of the project and figure out which guidelines have to be complied with in which section. So it's not like the project manager has to know everything by themselves, but it is important that they know who to talk to get the information they need, or especially Google. So always a good first bet is to just put the information that you're trying to search into Google and see what you can get, so you have some kind of idea before you talk to the person that can give you the more detailed input on what you need. So as you've seen, we have the functional and non-functional requirements. And for all of those requirements, for each of those, we have to define a certain test, and those will be documented as well. And by keeping track of those requirements that way, we can ensure that our project will be developed more smoothly, which leads over to keeping track of time. It is really important to keep track of like where you are in the project and where you should be in the project, because it is really hard, it is really easy to lose track of it at times. So it is important to visualize properly when things have to be done. Generally, for planning out the timeline, we have multiple tools. One of them being the Gantt chart, but this one has been covered in EPICS lectures so frequently that I'm not going to talk about it. If you want to know more about that one, just refer to the EPICS lectures that you can find online. The one I want to talk about today is the network plan, which is my personal favorite for project planning. It visualizes the logical process sequence of work packages with the meta potential method, and it shows the dependencies between certain work packages really easily. The hardest part about this is to capsule certain work tasks into own work packages, and so we can really determine which package is dependent on what, because it's important that they do not overlap to some degree. So let's look at one of those work packages. They usually have earliest start time, which you can find in this field, and the latest start time. This gives us the time frame in which we have to start the work package to not delay the project. And over here you can find the earliest and latest finish time. Again, if everything goes ideally, we'll be done by time step 6, but if we're not as lucky, then it might be time step 7. If it is time step 8 and we see that work package 2 is not done, we know for sure that the project is delayed. If you look here in the middle, you have the duration and up here the name of the project. Usually at a working package, usually you make sure that they have a speaking name. Just because this is a toy example, I just enumerated them. In a real network plan, never enumerate. Those names have to tell you clearly what they are. So for example, the first work package could be project definition, second one could be detailed requirement review, and those things, and you could build up dependencies on those. So now let's have a look at an example and how to build this network plan. Usually you already have determined the certain work packages, their duration, and which dependencies you have. So our first work package has a duration of 2 and no dependencies, so we can take work package 1 to the beginning and fill in its duration in the middle. We know that our project will already always start at time step 0, so we can already enter the 0 here. Sometimes the notation varies. Some people use 0, some people use 1. It really varies. Now we see that 2 other packages, 2 and 3, both are dependent on 1. So both will have an arrow from package 1 to them. And this tells us that those packages can only start once package 1 is done. Again, we can enter their duration in the middle, and the last one we can see has 2 dependencies, so arrows from both of those projects of the packages to this one. At this point in time, we don't need the table anymore because we have all the numbers and information we need to calculate all the other values in the table. If you look at the first one over here, we have that work package 1 starts at time 0 and takes a time of 2. Therefore, we can easily calculate that it will earliest finish on time step 2. We will continue doing the forward pass in the beginning, so we'll go on and follow the arrows. So if the earliest time work package 1 can finish, then the earliest time our packages 2 and 3 can start is time step 2, so we can move to those 2 cells as well. We can calculate the duration of both of those packages, so we'll end up at 6 and 7 by just adding up 2 and 4 and 2 and 5. And in this case, we have to propagate the numbers to work package 4. This is a little bit more complicated, but still fairly easy. In general, package 4 can only start once both 2 and 3 are done. So we are searching for the bigger of the earliest finish times of 2 and 3, which is 7. And then we can continue to the end of the project by just adding up the 2 in the duration. And we see that our project will earliest finish after 9 time steps. And usually we don't want our project to be delayed. So now when calculating backward, we assume that time step 9 is the same time step that we have for the earliest and latest finish time are the same. And now we do the same process backwards. So now we subtract the duration and get 7 again. Now in this case, 7 can just be moved to both package 2 and 3 because that's the latest time they can finish without us having a delay in our project. And again, we can just subtract the numbers and we get 3 and 2 respectively. For the backward pass, we have the exact opposite logic from before. So when we're searching for the latest time that work package 1 can finish, we need the smaller of the latest starting times of the 2 packages that it is dependent on, meaning that we need time 2. And then we can just calculate backward and get 0 there again. Now you see that for package 1, 3, and 4, we have identical starting and finish times. Those packages we refer to as critical packages because they have a buffer of 0. The buffer is always the difference between the earliest and latest. Well, technically latest and earliest. And therefore we can figure out what the buffer is. In any project, we want as few critical packages as possible because a path of critical packages will form a critical path. Whenever we have a network plan, we want to determine those paths because those are the project steps that are the most important for the project, because if those get delayed, the final deadline will pretty much hit the deadline. And in those cases, there are multiple ways to change those critical paths. One strategy would be to assign employees differently from the start and therefore change the times that a certain module takes. Another option is to add different work packages that are pretty much like miscellaneous bug fixing and put those buffer times in and therefore push the final deadline backward further. And when we use those, they're like, when we try to avoid those critical paths, sometimes it is impossible for us to use the ideal people for the project, so the durations of the single work packages might be longer than we want them to be. But there are many factors that go into that. For example, our budgets might not always allow us to have only the highly paid staff. In general, you can assume that someone who is new to the job and doesn't have as much experience will be paid lower than someone who really knows what they are doing. And while we really want the people who know what they are doing, it is too expensive to only use them. At the same time, the staff with the optimal skill set might just be unavailable. Various reasons could be there. They could be set on another project that we are working on, and we can only have them work on 1, maybe 2 projects, but then their productivity will already decline. And sometimes staff might just be on vacation. So especially in respect to the summer months, it is important to keep in mind that employees will be taking time off. Sometimes staff might just be pretty much gone for a month, and all of the team might be gone for a month. And it is important to have those things presented when planning out the timeline, and to also discuss with employees beforehand what their plans are, so we can pretty much take that into account. Another thing that will usually slow down the project is that we want to put new developers and pair them up with senior developers, so they get the experience of working in a project. So we don't only want the ideal people on the project, so we can pretty much train other employees to be just as ideal for the project. And all in all, assigning employees to certain tasks is a huge trade-off between time, cost, and quality as well, which is the usual project management issue that we are facing. If we want the project to be fast, we either have to spend a lot of money or the quality will be low. If we want it to be very cheap, it will either take a very long time or the quality will be poor. And if we want amazing quality, we have to expect to spend a higher cost or take more time. And overall, we are always trying to optimize on the 3 of them and find an optimal balance between them. On top of those issues, there's also the issue that oftentimes it is hard for us to tell how long a task is going to take and how much it's going to cost to do it. Because in many cases, we might have a similar project or a similar task, and we expect it, for example, to be 2 weeks, but then an unexpected issue occurs that makes it completely different from the prior one, and it might take way longer. So estimating that correctly from the beginning is pretty much an art form of itself. Always people are thinking to just putting more employees in a team if they need to be faster, but that only works to a certain degree. Productivity is not proportional to the number of employees. In fact, once too many people work on a team, the communication overhead will be so big that the team gets less productive. The same thing is the case. Like many project managers think that like if they increase the number of people on a delayed project, that will save the project and like get them closer to the deadline again. It might in some cases, but in many cases it actually slows down the people already working on the project because they have to teach the new people on the team how to access the code, how to deal with certain parts of the code. And then with this additional communication overhead again, the team gets slowed down significantly, and sometimes it might just be faster to keep the same people on the team. If they are delayed, they are delayed. We're just gonna sit it out instead of moving more people into the team. Another thing that always has to be kept in account is Murphy's Law. Project management and generally everyone leading the team or leading the project has to expect the unexpected. Usually there will be some part in the project or some moment in the project where things will not go as planned, and our plans should already reflect that we are ready to handle those. So for example, those critical paths, we already have those critical paths if everything goes as planned, so we definitely want to de-densify those. It is okay to have one critical path in the project. It is risky, but okay. Having more than one critical path in a project is highly discouraged from, because then you might end up with pretty much having files all over your project and not being able to react fast enough anymore. Now, with those issues that we have here, now the question is, how can Agile development potentially help us there? To understand that, maybe first of all, what is the issue with the traditional project management? And the major issue with the traditional approach, especially in the software area, is that there's a lot of bureaucracy. So the processes are very, very slow. And especially with software, if it's not deployed on time, it will already not be new. So having that software bureaucracy can be the difference between being market leader and completely useless and nobody will purchase it anymore. Another problem with the traditional approach is that the customer is not really involved in the project and can give feedback way too late. So you'll pretty much talk to the customer in the beginning of the project. Hey, what are your expectations? And then you don't see them until you hand them their deliverable. And they're like, this is not at all what I wanted. And then you have to circle back, lose a year of work or something, and continue again. And that means that the process is like way too slow, way too expensive, and super inert. And generally, you implement what is in the contract. As stated, you discuss via the files, and what is determined to be programmed will be programmed even if it's changed later on, and changes are really difficult. So if the customer demands a change in traditional project management, usually it will lead to new contract negotiations because changes are not really wanted and appreciated. So let's look at what the agile processes do different, or where like the mindset is different. In 2001, there was the Agile Manifesto, which still describes really well what is supposed to be done. So in agile development, we put individuals and interactions above processes and tools, which means that the relationship with the customer is more important than just stupidly following processes just because it is a process. So we still use processes, and like if you see here, it's like a table. The things on the left are more important than the one on the right, but we still have to use the ones on the right. And the important part is that functioning software is more important than detailed documentation, also built on the thing that if there is software that we're never going to use because it's broken and doesn't work, we don't need as detailed documentation. We still need documentation to be able to communicate, to keep track of what we're doing. So there's still a necessity for documentation, but to not overdo documentation and pretty much do the documentation that the customer actually pays for. The major part of being agile is to cooperate with the customer. So if the customer changes their mind in the middle, That's fine to some degree. Like if they have major changes over and over again, we'll definitely have to renegotiate contracts, and we always need contracts. But in general, it's more important to keep a good relation with them and keep the project going. It is also important to note that changes are expected, and therefore it is more important than following a detailed plan, because in most cases the master plan is gonna fall together over and over again. Let me go over what those 4 entail in a little bit more detail. So for individuals and interactions, it is important to note that everyone on the team is responsible for the final deliverable. It's not, oh, I'm only a team member, it is my project managers or team leaders' responsibility that I messed something up. Everyone is responsible to organize themselves, find something to work on, and if they break it, stand up for it, be like, yep, broke it, I'm gonna fix it now. And it is important to note that there are frequent meetings, but they are kept short. In many companies, they say they have agile processes and they have frequent meetings, but those frequent meetings are more like socializing and they don't really serve a purpose. They are lengthy, and that is not an agile process. In general, there are few team roles to keep it agile. It's not like you have those old-fashioned hierarchy structures. It's more like everyone is working together as a team. And it only works if the whole team acts as a team, so it's not really for single players. It only can work out if the team is highly qualified, so everyone can actually work individually. The team has to be small, because otherwise we get the communication overhead, and they have to be able to have a shared room, because that way they can just drop by another person and be like, hey, I have that bug, I know you had it before. Can you tell me really quickly how you fixed it, without all that formal back and forth of emails, calls, and other issues. And it really speeds up the team. How about the part with the functioning software? So you start with a really simple design, and then you solve the current problem with the current requirements, and you pretty much ignore later stages. And that way you can present a deliverable to the customer in really short release cycles, and test the deliverable over and over again, and have the testing be a central part of the development. So for example, once you finish module A or function or a certain function of your app, you can go to the customer and be like, hey, this is what we have so far. Is this what you actually wanted to have, or are we completely off track? And for example, if you have other modules that depend on module A, if you change that one again to fit the requirements, then you won't have to redevelop everything along the line by just getting the confirmation early on in the process. As stated, it is important to cooperate with the customer. It is important to include the customer in the team, have them join meetings weekly, preferably have them on site so you can actually read them and like talk to them casually while you're developing it. And it's important to note that the customer sets the priorities of what is to be done next. So, for example, there might be something for navigation, something for dining apps. And if the customer says navigation is more important, then the team actually focuses on what the customer says, because they are pretty much leading what is supposed to happen. It's not like the customer is like the only person deciding, it's more of a consensual thing. But in the end, the customer is the one paying for it, so they have like a bigger weight in making decisions. Now, as stated, the changes are an important part of the development cycle, and they are definitely accepted, expected, and can always be put into a new release. So if we show the customer the first version and are like, hey, do you like this? And they're like, no, I want this, this, and this change. That's no problem. We can just put it into the new release, and while we're working on the next release, if there's something else the customer notes, they can let us know, and we can just put it into the release after the one we are working on right now, and therefore keep flexible and improve incrementally. To make it possible to work that way, the contracts have to depend on effort and not on fixed functionality. We usually have a fixed price, but the functionality is formulated vaguely. So it could be something along the lines of, we will have a team of 10 people work in this project for an estimated time of 2 years. for this time, we calculate the following cost, and the functionality that we will deliver in this time is expected to be this, this, and this. And they can change over time, but usually it's more like a flat rate price for the work that is being done, and that's what a customer like leads where it goes to. And if the contract has to be extended, that is something that can happen, which usually happens if the customer is undecided and wants changes over and over again. So now let's compare the traditional and agile processes. So in the traditional process, it is unlikely that the customer participates really in the process, and we only know if the deliverable is useful after a long time, and we only have a deliverable after that time, really. And we make sure that it's developed correctly by having that lengthy specification and planning everything out, and then sticking to that master plan super closely. This method needs like a little to no discipline, because you have the traditional version of the team leader tells each person on the team precisely what to do, so the person leading the team has all the responsibility. And changes are generally fought because like it is not in the contract, and there's a lot of communication via documents, and you try to avoid changes by just planning ahead and avoiding them. While this approach might have some advantages, for software projects, it's usually way too slow. So in that case, the agile processes are way better. Over there, it's important that the customer is in there. In fact, if the customer doesn't really participate in an agile process, there is no agile process, and the development process will fail for sure. And in agile processes, usually you have a deliverable every 6 weeks, and that way the customer really knows where the project is at, and they feel like they are involved in the process, and they're usually more happy with what they get, because after 2 years you handed in some document at some point, and the technology changes, so sometimes you might want to have a little change in the middle where it's like, oh yeah, I thought this would be amazing, but now looking at it, it is not, so can we please change this slightly to portray this? And in the agile process, that's something that is done really quickly and easily. In general, we develop the core incrementally, show it. If it's good, it's amazing. We go on to the next one. If not, we improve what we've done so far. The problem with the agile process is that it needs a lot of discipline, and it's very informal. So everyone on the team has to actually pay attention that they actively help the team, that they don't get distracted, they are not idle, but like actually work and are productive. In that case, changes are definitely expected, they're tolerated, and it's not a problem at all. But the communication is way easier, so you actually interact between people and not with a document, which makes the process easier. It's also easier to like understand, because if two people are in the same room, they can just sketch something out on a piece of paper and be like, hey, this is what I mean, do you understand what I'm trying to say? Whereas which a document is a little bit harder to obtain. And with the agile process, like we are not really trying to avoid changes, we're just trying to stay flexible, so if we get a change, we're able to apply that change easily. So with that, let me come to my summary. So for project management, it is very important to make sure that the methods for software development are being used, because those can help us to avoid system failure, to make sure that we're staying on track, that we have means that make it easy for us to track where our project is. By using standardized procedures, we can make the work easier for ourselves, and we can check where we are in the process way easier, and we can distribute the process over multiple teams or even multiple countries and time zones. It is essential for us to determine the requirements properly. In many projects, people tend to rush over the requirement determination because it's like, oh, they are not really important, we want to start working, we're excited, but it is important to have that fixed. In the traditional process, even more so than in the agile process, because in the traditional process, if it's not in the requirements in the beginning, the deliverable might be completely useless, and not having the right deliverable can be very costly because everyone has been working on a project for so long. There are multiple tools for timeline planning that can help us keep track of the project. For me personally, it's the network plan, but everyone has their own preferences there. And the agile process might benefit certain projects. It needs to be noted that not always agile is the solution to us. As stated, the team has to be small, they have to be highly skilled, they have to have a room where they can work together, and then everyone really has to want to do it. In many companies talk that they have agile processes, while in fact they don't. So they call it agile, but in fact it is a new kind of bureaucracy that is very slow and inert. So with that, thank you for your attention. You're very welcome to ask questions. I'm just gonna close the presentation for a moment to be able to close the recording.